We're continuing with vectors, and we're going on to the vector operations, where we're going to focus on this video on scalar multiplication. If you remember from matrices, scalar multiplication is where you distribute through a multiplier. And then the other thing we're talking about is vector addition, adding two vectors together, and what would happen, what would they look like. So please go ahead and just pause and read through this paragraph. Okay, so you have paused. When we add two matrices, or not two matrices, when we add two vectors together, you start by joining the initial vector of u. And you take that terminal point and add the second vector of v. And what you get, so if I have a vector here, this would call this vector u, and I want to add vector v, I would start my next vector there. And what happens is you get this parallelogram law, and we'll show it in a better example, and that will be your resultant vectors, that direction across. All right, so here's an example. So we give you this vector u, so I'm going to color this one on the left in black to green. And then what we want is this other vector v. So those are my two separate vectors. In our operation, that what we want to do is we want to add these two vectors together. So this will be our operation over here. So what you do is you start with the first vector, u. So here's my u. Now imagine picking up this red vector right here and moving it to the terminal. This is my terminal for my first vector. And I'm going to do the same direction and the same magnitude as the v vector. So now I've added these two vectors together. Now what happens is if I change colors to blue, that is my new resultant vector in the blue here, going straight across from my initial to that finishing point. That's how you can add two vectors together. Now here's some definitions for vector addition and scalar multiplication. So let's say we have two vectors, and you want to add these two vectors together. So notice that this is in component form, not as an ordered pair. And this one is also in component form. If you want to add these two vectors together, you would add u1 and v1 together. Then you would add u2 and v2 together, and you would get a new component form for the sum, the addition of those two matrices. The second operation is the scalar multiplication. If you have some scalar here, you can distribute it through to both pieces of your component form. So you had k times u sub 1 and k times u sub 2. The next piece is you can negate a vector. So you're just like a scalar multiplication, you're throwing the negative 1. So you'd have negative v sub 1 and negative v sub 2. Now we do have to be a little bit careful if we want to subtract, take the difference of two vectors. So again, you should be writing this down. If you want to take the difference of two vectors, here is u minus v. Notice the operation, it's plus. We've already done that operation, but now we're taking the negative. So it's going to be u minus v sub 1 and u sub 2 minus v sub 2. So here's an example below in this figure of subtracting two vectors. So I'm going to color code this first vector u. So that's my original vector. And here is my v, my other original vector. And what we want to do is we want to do the operation of u minus v. So we are going to start with u and then go backwards v. This would have been forward v. We're going backwards, so we're negating it. And then now this is our ending point. So I gotta change colors here one more time. And now we start with that initial u and head to our ending right there. So here is now our new matrix, right? Not our new matrix. I keep wanting to say matrix. Here's our new vector right here. All right. So that's how you can subtract 2 by doing the negation. All right, here are some properties for you to pause and write down for vector addition and scalar multiplication. U plus v equals v plus u. That's your associative. Number 2, that's your associative. Oh, number 1 is commutative, associative, identity, etc. So you can read through those.